Great, and thank you so much, Lenka, for the introduction. And everyone, good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to the Sisters Tech Talk on the foundation of cloud computing. First, I just wanted to take an opportunity to say thank you to all of you for agreeing to be here and listen to what I consider to be a very important and timely topic. I'd also like to extend a thank you to Sisters and AnitaB.org for allowing me the opportunity to talk with you today. So a bit about myself. I am Susanne Tedrick, and that is a slightly dated photo of myself, but I am a client technical specialist with IBM's Cloud Platform Division. I primarily work with developers and project managers in helping them create cloud native or specifically applications that are specifically using cloud components, as well as how to modernize their existing applications. I primarily work in the platform as a service area, or PaaS, and that is actually one of the things that we'll be discussing later on in the next couple of slides. Aside from the fact that I work in the cloud computing space, there were a number of reasons why I picked it for this particular webinar. First, it affects everyone. You would be very hard-pressed to find any particular person or business that hasn't been impacted in cloud computing in some way. If you've used a service like Gmail, or if you've used streaming services, media services, social media, you have used cloud computing in some capacity. And as time grows on, as people become more and more reliant on cloud computing, that will always be the case. Second, it's critical to businesses and people alike. People are no longer willing to wait around for businesses to supply them with the products and services that they're asking for. And businesses can ill afford to wait around to provide those services at the risk of people using another provider or another service. It's becoming crucial for people to rely on cloud computing services just to get the day-to-day done. And finally, it's a really exciting, growing, and highly complex field. Cloud computing is not necessarily a singular technology concept, but rather it takes in a number of different ones and how they all interrelate to one another. It can be really difficult to kind of parse through that complexity. And as we become more and more dependent, you're going to see that complexity grow. The field is growing every day, and the more that you are aware of how these interconnecting technologies work with one another, the better served you'll be in both an academic and professional stance. Employers are always saying that they don't have enough people with cloud computing skills, and that looks like it's going to increase over time. Our agenda for today, we're going to talk about cloud computing at a high-level overview, and then detail that with the National Institute of Standards and Technology's definition of cloud computing. We'll go over cloud service models as well as deployment models, and then go over on a high level some subjects that I think will be helpful to deepen your understanding of cloud computing. And then finally, some next steps that you can take as you decide to deepen your knowledge of cloud computing. So before we begin, I actually have a poll question. So Lenka, if you could show question number 1 for me, please. Okay. So just to gauge, how familiar are you with cloud computing? Are you very familiar, not very, or at all? And if we can just spend like a minute or two to vote on that, that would be great.
I think most people already voted.
Okay, so if we can go ahead and close the poll. And thank you for doing that. Okay, good, good, good. Well, thank you for taking the moment to participate. The prerequisite for this wasn't to have any necessary cloud computing knowledge. This was just for me to get a sense of where everybody was in terms of their level of understanding. This webinar is entry level in nature, and so we're going to keep it at a very high level. If there are further questions or things that you would like expanded on further, I'm more than happy to answer that at the end of the webinar or offline. Okay, with that, let's get started. So what is cloud computing, really? My oversimplified, oh, going too fast. Let me stop that for a second. Come back here. Okay. Can you guys see the screen again? Sorry about that.
No, not yet. We can
Not
see
yet. Okay, let's go back. I love technical difficulties. No, not really. Okay, let's see what happened here. Okay, can you guys see my screen now?
Yes.
Okay, let's go back to where we were, and thank you for being patient. Okay, so my very oversimplified answer to what cloud computing is you're essentially just using someone else's computer to do things. Now you might ask, well, why on earth would I want to do something like that? Why would I want to use somebody else's computer to get stuff done? Well, let's break that down a little further. Let's say you have a project that requires a significant amount of computer processing power. Now, you may have a laptop or a desktop at home, but it's not enough. And even if you decide to go and upgrade it, it's not going to give you what you necessarily need. You also may not want to go out and buy more computers if you don't necessarily need to, especially since you know that this project is probably going to be a couple of weeks at most. So rather than doing that, you would go and you would talk to a cloud service provider who has a data center similar to the one that is on the right. That way, you would directly use what they have in their arsenal, not having to worry about electricity, upgrades, space, cooling, or human resources to keep that up. All of that would be managed by your provider as opposed to something that you would have to do, saving you time and money in the long term. Taking it down to a more personal level and slightly dating myself, I want to take the example of word processing. When I was in school, when I needed to type up a report, I needed to go out and buy a copy of Microsoft Word. When I bought the copy, it was single use, so I couldn't share it, and it had to be installed locally on my computer. And it was fine for that one-off paper that I had to use, but once I sunk in the $99, I couldn't use it. You know, I couldn't use that money for other purposes. It was a sunk cost. I also couldn't use Microsoft Word on any other computer except that particular computer. Fast forward to now, we have Microsoft Word, part of Office 365's Office Suite. And so for that, instead of installing it on my computer, I can use my computer, my tablet, my cell phone, anything to go ahead and start writing up a paper. Instead of paying $99 for flat, I can just go ahead and pay $9.99 per month. And if I decide, okay, I don't have any more writing projects that I have to do for a significant period of time, I can tell Microsoft, you know, let's cancel my subscription, and I can use that money to do other things. I don't have to worry about any upgrades. I don't have to worry about installation on my part. Everything is handled by Microsoft directly. And this just illustrates why cloud computing has become so beneficial to businesses and people alike. It's incredibly efficient. It allows you to spend your resources where you want to spend them as opposed to feeling like you're fixed into something. It's flexible. If you find that your needs are growing, you can get more resources as necessary. If you find that they're decreasing, you can adjust that as well. And it's incredibly cost efficient because you're not spending money on necessary hardware, software, electricity, human resources, and a number of other areas. This is not to say that cloud computing is 100% foolproof and that it doesn't have its issues. And for anyone, regardless if you're a business or yourself, you'll want to really think about some of the things that may deter you from selecting a cloud service provider. One thing is reliability. How reliable is a cloud service provider when everything is said and done? If their infrastructure goes down, you're not able to access any of your files or any of the things that you might have decided to get from them. Your privacy is also an issue. What does the service provider do with your information once they have it? And that's something you want to be very careful of when you're signing up for certain cloud services. There are some service agreements that explicitly say that any information that is uploaded to their cloud becomes their intellectual property. And so what do they do with it from there? Do they sell it? Do they sell it to other third parties? Those are important things to know. And then finally, how secure is the platform? With cloud computing, depending on the service model you're talking about, you're giving up a little bit of control or a lot of control to the cloud service provider over things like security. Whereas on your own personal computer, you can install a firewall or other protection services. You can't really dictate what a cloud service provider does. It's literally, I've given you money and you do what you're going to do. So understanding how a cloud service provider approaches things like security is incredibly important. So we talked about the definition, but there's a definition that is widely used across the industry, and that is by the National Institute of Standards and Technology. And before we go into their definition, we should spend some time talking about what they are and why we use this definition often. NIST is a government agency that helps to govern standards on measurement in a number of different areas. So you'll probably see them in areas like industrial or manufacturing and even technology. We use their definition because it's generally accepted across the tech industry. And honestly, cloud services are not the same between providers. For example, if I say that I work in platform as a service with IBM, that's not necessarily indicative of what a platform as a service would look like for another company. It might be completely different. So when we apply this particular definition, it helps us to level set our expectations and conversations with one another so that we're talking apples and apples and oranges and oranges. So this definition of cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, for example, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. That was definitely a mouthful. But if you notice on the screen, there are words that are bolded. And these particular bolded words are what we should be concentrating on as try this again. Okay. Here we go. The 5 characteristics of cloud computing. The 5 characteristics are on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. We're going to take a moment now to explore these individually. When it comes to on-demand self-service, this means that a user can go to the service provider's website and access services when they need to. They don't need to wait for anyone from the service provider to grant them permission. It doesn't require them to intervene, or it doesn't really require them to wait. So for example, if you use Gmail, you don't necessarily need to contact Google directly in order to access your email. You just log in and access the email as you would like to do so. Broad network access means that services can be accessed through a network or internet connection. They can also be accessed through different devices. So you can access Amazon through a laptop or desktop computer, through your phone, through a tablet, or any other device that has an internet connection and some type of web browser like Google Chrome or Safari. Resource pooling allows service providers to serve multiple clients or tenants at the same time. You may have heard the concept of multi-tenancy, and that's essentially what it means, serving many people all at the same time. The resources that are dynamically assigned are assigned according to the demands of the users. With rapid elasticity, users can consume as much of a service or as little of a service as they need when they need it. To kind of picture the concept, I use two different images. The first is that of a rubber band. A rubber band can expand and contract as you pull it into your needs. It's also kind of like a food buffet, because when you pay for an all-you-can-eat buffet, you can get as much of a food as you want or as little. And every time you go back, you can make a decision of, I want more cheesecake versus I want more vegetables on my plate. It's just a way to use things as you see fit, and you're only charged for what you actually use. And finally, measured service. So this means that the cloud service provider only charges a user for what they actually use. The usage is monitored and controlled and reported to the user for the sake of visibility and transparency. It's kind of similar to a utility metering. And so you'll see the electric meters that are on the screen. When you get your utility bill, you are charged for what you actually used. And it's no different here. You're not charged for what they think you could use or what they believe that you could use in the future, but literally what you used during that time frame that they charge you for. Okay. Lenka, it's now time for our next question. And I believe that's question number 2. Which one of these is not considered a NIST characteristic of cloud computing? So if you can just take a moment to answer that question. Do you think we have everyone, Lenka?
I'm trying. Yes, most people, I believe, looks like answered. Okay, I'm gonna switch to end.
Okay.
And share results.
That's exactly correct. Thank you for participating. So yes, open source is not necessarily a characteristic of cloud computing. What open source refers to is the idea that software and the underlying principles about it can be freely shared with one another without there being fees or other things attached to it. Now, many cloud service providers do use open standards of technology, But that isn't to say that that's a hard and fast rule for anyone to be a cloud service provider. That's also something you'll want to think about too if you exclusively use one particular service provider, to make sure that if you decide that you no longer want to keep your data or use their services, how easy it would be for you to migrate that over to another cloud provider's platform. Okay. Let's go ahead and move on to cloud service models. So if you look at the screen, you'll see what is a typical IT infrastructure that's managed by an IT department that is on premises or essentially physically in the location where the business is located. Now, IT departments are usually responsible for all of these particular things. We've got applications and data, which is what the end users use, your runtimes, middleware, and operating systems, which kind of act as the in-between between those applications, and then the connecting part of virtualization, servers, storage, and networking. Now, managing all of these things on your own can be very cumbersome and costly. And so this is where the service models of infrastructure, platform, and software as a service come in. With infrastructure as a service, or IaaS, the task of managing the servers, storage, and networking becomes the responsibility of the cloud service provider. The service provider is responsible for the housing, the maintenance, any changes or upgrades that need to happen, and all the related activities of such for the equipment. The end user that uses the infrastructure has no say to govern what happens at that level, because that belongs to the cloud service provider. However, they still do have the ability to create and run software and applications on those particular services. Many companies use IaaS as a way to store data or just to run applications instead of investing in server and storage on their own. Platform as a service, or PaaS, allows users to develop and run their own software applications. You can also too deploy these to the cloud. And what deploy to the cloud means is that rather than having your software run just on your computer, you can run it on a cloud server that will allow people to access it no matter where they are. And in some cases, this is a really good idea. So if you are in an industry where your busy times vary, like let's take retail, for instance. If you're a retailer and you know that the busiest time of year for you is usually around the holidays, then you're going to want to have an application that can rapidly scale to what you need it to do. So deploying to the cloud makes sense because it's able to handle as much workload as it possibly can. And then when the busy season is over, you can just go ahead and decrease your services as you need to. So again, these are what is managed by the service provider, and the company only worries about the applications that rest on top of it. Software as a service encompasses everything. This is the point where they're in touch with the applications, your operating system, servers, storage, networking, everything. And examples of this in everyday include things like the Google Docs, or anything dealing with spreadsheet software or presentation software, things of that nature. This is great because you only pay for what you need and you only pay for licenses that you need. The only thing that really is not so great about it is that you have no control whatsoever over any aspect of the stack, except for perhaps maybe changing the configurations or changing the number of licenses that you have. All of this is pretty much dictated by the cloud service provider. So if you needed to make a change to the underlying application's code, or if you wanted to have an understanding of what operating system that they were using, that's really not something that you can do at software as a service. But it is convenient, and it takes a lot of the burden off of you if you don't really need that level of sophistication or customization. Okay, Lenka, could you show the next 3 questions, please?
Okay,
Okay, so let's go through this one. Google Docs would be an example of SaaS, PaaS, or IaaS. I'll give you a few seconds to answer that one.
it looks like most people answered.
Okay.
I will end the poll and share results.
Excellent. Yes, Google Docs would be an example of software as a service or SaaS. Okay. Next question.
Following question.
Amazon Web Services, Azure, Google Cloud Platform, and IBM Cloud Platform are examples of SaaS, PaaS, IaaS, or PaaS and IaaS.
Okay, I think we can close this poll.
Okay. Great. So it's actually PaaS and IaaS. And the reason being is that all of them have what's called compute and storage, which includes processing servers, processing power, as well as places where you can store documents and other types of data. But they also allow you the opportunity to develop software that is cloud native. So it's an example of both PaaS and IaaS. Okay. And Lenka, this will be the last one for this one.
One more.
Okay. Netflix, Hulu, and Spotify are examples of SaaS offerings. Yes, no, or maybe it depends.
Okay, I will close this poll. And results.
Okay, so this was definitely a trickier question. So I'm going to go with maybe it depends. So if we talked about SaaS in the purest sense, we're getting a service from, we're basically accessing a service from somebody else's server. So in that respect, Netflix, Hulu, and Spotify could technically be considered SaaS offerings. But depending on who you ask, they would not be considered SaaS offerings, but more so streaming video on demand or streaming media on demand services, as opposed to SaaS, because you're not necessarily using them to enhance your productivity or to create presentations. You are just kind of consuming data. So this is why it's always helpful to have definitions around things, because what something means to one person may be different than someone else. All right, great job, everyone, and thank you so much for taking the time to do that. Okay, we'll now talk about cloud deployment models. Public cloud, as it suggests, is available to the public. It is generally available to anyone that wants to use the provider's services and hardware and storage. Cloud services tend to be cheaper than a private cloud or any other type of deployment because you're all kind of sharing the burden of the cost. And most of the major web providers, or sorry, cloud service providers, have free tiers that you're able to go ahead and spin up their services as needed. Community cloud isn't really used very much, but it is a way for people who, or rather people and organizations that share a common goal, interest, or concern to share the burden of those cloud costs. Now, it can be owned or managed by one or more several organizations, but it isn't something that would be necessarily available to a larger community, but rather a select few. Private cloud is only accessed by a single business organization or entity. Now, you can deploy this type of cloud or make available this type of cloud on your physical premises or in the cloud. So for on-premises, you would install the software behind the firewall on your server, or you can go to a cloud service provider, and rather than say, I want to share server space with other people, you can purchase a virtual server all to yourself. You'll generally see this type of deployment in organizations that really place a premium on security, privacy, and reliability. So for example, the health industry or financial services or any other mission critical organizations that really need to have dependability at the top of mind. And then there's hybrid cloud. So hybrid is a combination of two or more distinct private and public clouds. Now, they're not necessarily merged together, but they are in a way linked together so that you can share and transmit data between them and enjoy some of the benefits of both the private and the public cloud. So why would you need a hybrid cloud type of deployment? You may be an organization that has a set level of data that could be private or very sensitive, and it's crucial that you keep it behind your firewall. However, you do want to enjoy the benefits of the public cloud because it's cheaper and a little bit more accessible. You find a way to link those together, creating kind of a hybrid cloud environment. This shouldn't be confused, though, with the idea of multi-cloud, because multi-cloud encompasses several different clouds that aren't necessarily linked together in any coherent way. If you have heard of the security company McAfee, the average American employee uses anywhere from 5 to 36 distinct cloud providers during the course of their work week. So that's where it's more of a multi-cloud versus hybrid cloud. Okay, Lenka, could you show our last two questions, please?
Sure.
Okay. The most common cloud deployment model is private, hybrid, public, or community.
Okay, I will end the poll.
Thank you, guys. So it's actually going to be public. Public is the most common, only by the sheer fact that it is the most accessible for most of the population to have access to. Lenka, the last question.
And there's two more.
Oh, there's two more.
I guess that's the last one. I think it's reserved for the very last.
Okay, got it.
I believe.
Okay. A private cloud deployment would be appropriate when you want more security than a public cloud, you want more privacy than a public cloud, you have heightened concerns over reliability and availability, or all of the above.
Okay, I think we have most of votes.
Spot on, guys. That is absolutely correct. You're concerned about all of these things when choosing a private cloud deployment. While private cloud deployments may cost more money, if those things are of concern to you, it's worth the price. Great, thank you. So I've given just a general overview of what cloud computing is per NIST definitions. And as I mentioned earlier, it's not one subject, but it is the culmination or the interchanging of many altogether. And I want to recommend a couple of specific subjects that I think will be helpful to deepen your understanding should you want to learn more about this very exciting part of technology. Now, whether you decide that you want to become more advanced in your understanding will depend a lot on your interest and what career fields you're interested in. But these are really helpful in just knowing in general to have a good sense of what cloud computing is. If there is one subject that I would recommend more than any others on here, it is computer networking. Networking is the backbone of the internet. There's no getting around that. And having a good understanding of how computers communicate and share resources with one another, whether they're local or across the world, is very crucial for deepening your understanding of cloud computing. Virtualization is also important. Virtualization allows you to operate two or more different types of operating systems on one specific computer. You'll want to understand the different types of virtualizations that are out there, like hardware or software. And you'll want to understand when it would be advantageous for you to spin up a virtual machine, or when would it be more advantageous to do something else. Containerization allows you to create, package, and deploy applications that are cloud native. And this is a very growing, very popular area of cloud computing. And so for those that are interested in cloud application development, I strongly suggest becoming very well in depth about the subject matter here, understanding what containers are, the different types of container technologies that are out there, like Docker, orchestration systems like Kubernetes, understanding microservices architecture, which looks at breaking down very big applications into specific services. All of that is going to be necessary to build your understanding of containerization and of cloud native application deployment. Understanding the basic functions and components of major operating systems is also important, as your operating system is the central nervous system, rather, of your computer. It allows you to interact with your computer in a way that doesn't require you to constantly use code in order to do so. It also helps to manage the limited resources that your computer has to do certain functions, like how much resources should they allocate to memory, how much should they allocate to storage, and so on. Understanding the major operating systems that are out there, like Windows, Linux, and Mac OS, as well as the mobile operating systems like Android and iOS, are very helpful. Programming allows you to use code and analytic and problem-solving skills to develop applications. I'm making a differentiation between programming and coding because coding is more so concentrated on understanding the basic context and syntax of a particular language. With programming, you're kind of applying a little bit more thought and time into constructing an answer to a problem. And it does require a little bit more work and savvy to do. If you are interested in any specific language, I know that Python and JavaScript are very popular, but don't feel that those are the only languages that you can study, or that those are all inclusive for cloud native application development. There's many others out there, and so just taking the time to learn a couple will improve your career standing. It also helps to know more about application programming interfaces, how you can call data with code in a little bit more detail, and then understanding the difference between full stack, front end, and back end development. The full stack meaning I'm concentrated on the out layer that shows up to people, as well as the back end that comes in with databases and storage. Or do I just want to concentrate on one specific part, meaning concentrating on the design and what the user sees, or specifically the back end and database? And finally, cybersecurity. And I think that's a subject that everyone should try to get more familiar with in general. Knowing how to protect your applications and knowing how to protect your infrastructure is incredibly important, as the number of bad actors and viruses and other things are increasing in number as we become more dependent on cloud computing. Now, while if you're using a as a service model, you may have less control over the security than you'd like. But if you have a good understanding of certain standards that are out there, it will at least help you to pick a cloud service provider that is more akin to where you'd like to be in terms of your security. Next steps. This is my advice for anyone that wants to deepen their knowledge, and definitely not an exhaustive list of things. But I say that the most important thing is experimentation and practice. I strongly suggest experimenting on the different cloud service providers that are out there. So Amazon, Azure, Google Cloud, and IBM Cloud all have free tiers that you can use so that you can go ahead and build and create to your heart's desire. If you happen to be in school, I know that all of them also have more aggressive academic discounts that you can use. So definitely feel free to poke around and play around and see what you can create. That's usually the best way to go about learning the cloud platforms. And as we become a society that uses so many different types of cloud providers, knowing how they all connect and play with one another is also a crucial thing to know. For those that want to learn more about networking, there is a program called Cisco Packet Tracer, which allows you to simulate networking scenarios on your own and understanding how to set up your own local area network or a wide area network. Networking is a difficult subject, and I think that having the hands-on experience will make that a little easier. With regard to programming, I say start with one language, really get to understand it and get a feel for it, and then try to branch out into others, because it will make learning other subsequent languages a little easier. I advise starting out with a fairly low bells and whistles text editor versus an integrated development environment. The difference between the two is that an IDE will give you all of the functionality, debugging, running the program, things of that nature, but it won't really tell you like where you've made mistakes or how you can correct a mistake. A low-level text editor will allow you to review those things and really learn where you may need more help and more guidance. Practice using the command line interface. Depending on what kind of operating system you're using, it might be called terminal, it might be called CLI. It really depends on what your operating system is. There are a number of different platforms that allow you to interact with your computer graphically or perhaps coding without having to necessarily type these things out. I will say that using the command line interface is a lot faster and easier. And once you have a handle on the different commands that are available and the things that you can do, it will improve the time that it takes for you to go ahead and execute commands. And if you want to learn more, there are a couple of resources that I have found helpful. There's a site called The New Stack, which focuses on cloud native development for both infrastructure and platform. It talks a lot about the industry players as well as the newer things that are coming on scene for that particular area. Techopedia has been really helpful to me because there are certain terms that when I see them, I'm like, I have no idea what that means. And Techopedia is great in that it just breaks it down into plain English for you so that you can understand the concepts better and without necessarily the hard pitch of trying to sell you an item or a service. And there are a ton of online courses that you can take. The ones that I recommend are through Coursera, Udemy, and edX. It has been a pleasure being with all of you today, and I strongly encourage all of you to keep in touch with me. I'm more than happy to answer any questions or concerns that you may have. On the screen are the different ways you can reach out. I'm available by email at suzanne.tedrick@ibm.com. You can also find me on LinkedIn and Twitter. And for those of you on the question and answer site, Quora, I do answer a number of general cloud computing questions. So feel free to ask questions there as well. With that, thank you.
Thank you very much, Susanne, for the wealth of knowledge and introducing us to cloud computing. Although we have only like 7 minutes until the end, I want to encourage everyone to, if you have a question, type it into the Q&A icon down below on your screen in Zoom. And because we don't have much time to answer possibly all of them, I will ask, oh, there's one in chat. I will ask Susanne to maybe select or just answer the first 1, 2, depends how much time we're going to have, and the rest, if maybe Susanne would like to answer them via the link shared. Is that possible if people have more questions afterwards and we run out of time?
Yes, absolutely. Please feel free to contact me in any way that you'd like. I can't unfortunately see I see that there's something that says Q&A, but
no. Oh, you cannot click on that?
No.
Okay. I can put it for you in chat. So yeah. Okay, there you go.
Is DevOps part of cloud computing? That's a great question. So DevOps is used in cloud computing. It's more talking about the cultures and the mindsets that are necessary to build applications that not only make the developers happy, but that the operation staff can use with one another. Very often what tends to happen in development environments is that they tend to just kind of silo themselves and think, oh, this is great software. But then when it gets to the operating staff, they're like, this software does not help in any way, shape, or form. So DevOps is more of a methodology that you can build technology together. This way, it's making something that is useful, is mission critical, and satisfies the requirements of the business.
And we still have 5 minutes, so we can take at least one more question. Okay. Here we go. I'm again trying to. I posted it for you.
Okay, so I'll read the question. My question is, if I want to advance my career in cloud computing, getting the certification Azure Google platform helps. So I think, yes, generally speaking, I think getting those certifications are definitely something that can prove to potential employers and others that you're definitely someone that not only has the technical knowledge, but that you do have working experience in those platforms. I will say that a certification shouldn't be the stop, or it shouldn't be the goal. The goal is to try to develop as many skills as possible, gaining awareness of the industry, gaining awareness of, you know, things that are going on. Because the downside with certifications is that eventually they do tend to go out of style, and then you're kind of back at square one. So I would say definitely, if you can and you're up to it, I would definitely pursue it. But don't let that be the end of your education.
And we still have time. One more question. We have 3 more minutes. So if anyone still has a question, please type it in. Okay, there's one more.
Okay.
And I can read it to you. What made you interested in cloud computing?
That's a great question. I think it was just realizing it's far more advantageous to spend money in other places than it is to constantly buy hardware and software for certain things. I mean, when I was younger, I used to like put computers together, and that's great as a hobby. But when you talk about the upkeep and the maintenance and so on and so forth, it adds up. And then depending on what you may have going on in your life, if you have school or work or other things, you don't have the time to really devote to upgrades and purchasing software and everything else. And looking at cloud computing, I mean, cons and risks aside, it's a really disruptive technological concept, and that always like interested me. How it's not even just a business that cloud computing has disrupted, but it's disrupted how people consume services and products. It's disrupted how people program. It's disrupted how people manage their operations. So it's one of those technology concepts that literally affects everyone, not just one subsection of the population.
Okay, and I believe we're out of time for now. If you have more questions, please send them to Susanne directly, and she will answer as much as she can. Thank you. Thank you, Susanne, so much for this wonderful, educative topic, and we would like to welcome you again in the future if you would like to present another topic to our community.